Welcome everyone. Welcome for this new live session. Let me just mute my the audio back. Great. Take a seat. Welcome, welcome. As usual, we'll wait for a few minutes so that everybody can join us. And that we'll get going with today's session. Yeah, and so today's session will also be the last one for this season because summer is pretty much here now, and so a lot of people are not as focused as during the rest of the year, so it doesn't necessarily make sense to continue to hold these bi-weekly sessions during the summer period. On top of that, I'll take some vacations as well, and it's getting a bit hot where I live as well, so it will be less and less comfortable for me as well. So I see we have 2 viewers on YouTube. Feel free to say hello in the YouTube chat, or if you're already on the Telegram, you can also say hello in the live chat channel on Telegram. Speaking of Telegram, if it's your first visit here, know that we also have a Telegram group which you can join using the invite that is on this QR code. And just to introduce quickly what Plan B Labs Lighting is, basically the idea is to have a community where we can keep track of recent developments in the lighting ecosystem at large. As the name lab implies, it's rather focused on more technical aspects of things, not necessarily, business side and this kind of stuff. It's more on the technical side, but not necessarily very, very technical. It depends on the subject. So we have this Telegram chat where we hang out between sessions, and every 2 weeks we have a session. So as I mentioned, this one will be the last one of the season, so there will be no session in 2 weeks. But we've held already, I think, a dozen of sessions because today is number 11 and we started at 0. Okay, great. And so now without further ado, maybe we can start with today's session. So there are 3 main topics I wanted to cover today. One is following a message posted by Rosebeef around on Delin Bitcoin around onion messages and maybe proposing an alternative way of doing onion messages in terms of on what layer we send these onion messages. And related to that, I wanted to touch on a new protocol, a new meta protocol called Clink, which is proposed by Justin from Shocknet and Lightning.pub and things like that. Which so kind of makes sense to talk about with regard to Rosebeef's proposal, but also on its own as well. And then some wallet updates with many wallets integrating Spark, wallet of Satoshi announcing a self-custodial version, and more stuff. Let's get into it. And I see, Justin, that I don't know if you watched the live as well, but I see that you joined the chat, the Telegram group. If at some point you want to jump in with me, it's totally possible. I can give you a link and you can join me on stage, or if you'd rather just hang out in the chat, it's also fine. But be aware that I can just send you a link and you can join me here if you want to have some higher bandwidth discussion on either Onion messages, because I know you have some strong opinion around Bolt 12 and Onion messages, or more precisely on Clink as well. And so roast beef, let's get into the Onion messages discussion. Roast beef. So for those who don't know roast beef is a pseudonym, and I won't try to pronounce his name, his actual name. He's notably an LND developer, and so he posted, here on Delvin Bitcoin, a post entitled "Reimagining Onion Messages and an Overlay Layer." Nope, here we go. And so basically, the idea what he proposes is to use an alternative communication layer for Onion messages. But maybe before we delve into that, it would be good to just recap quickly what Onion messages are. So Onion messages are relatively novel. So I say relatively because they have been around since maybe a few years now, but they are not necessarily fully implemented on all implementations, and their usage is not that widespread just yet. But yeah, they are getting more and more traction. And basically, the idea is to be able to exchange messages between two Lightning Network nodes without having to rely on any external software. So you just have to run a Lightning node that supports Onion messages. You don't have to run a web server or anything on top of that. And one of the main use cases of Onion messages is for Bolt 12 offers. So here you have a reminder of what Bolt 12 offers enable. And so basically the idea is that you can have a static QR code or a static string. And one of the use cases of offers is that you can just reuse them as a static payment identifier. And then every time someone wants to pay you, they just have to grab the offer that you previously posted somewhere, for example, on social media. And then they can use this offer to fetch an invoice using an Onion message. So basically, the node is sending a message to the other node, and we'll see how it works in a moment. And then the node responds. So the recipient checks that the offer is valid. So basically, that the fetch invoice message corresponds to valid offer. And if it's the case, it will respond using another Onion message with an invoice. And now that the sender has the invoice, they can just pay the invoice as we do regularly on the Lightning Network. So as the name implies, Onion messages are routed across the network. So here you see we have arrows going from the sender to the recipient, but what is actually going on is that the Onion messages, so the fetch invoice and the message containing the invoice, are not necessarily sent directly from the sender to the recipient and vice versa, but rather theoretically they are routed through a network of nodes, of Lightning Network nodes. And so they are routed across the network with Onion routing. And the name Onion messages. So it really resembles the way that payments are routed across the network. And one of the main reasons to do that is, of course, privacy, because this way you have the privacy of Onion messages is quite similar to that of payments or Lightning. For example, the recipient doesn't know, presumably, that who the Onion message originated from. Any routing node doesn't know who is the emitter of the message and who is the recipient, and so on and so on. That being said, of course, you have the same kind of limitations to the privacy of Onion messages than what you have with payments. But still, it's important to be able to have this kind of private messages because we have adequate privacy for especially for senders on Lightning. And so if you have great privacy when you send the payment, but your privacy is degraded when you request an invoice in order to be able to send the payment, then there is no point in that. So that's why it's important to have a quite private layer to fetch invoices between Lightning nodes. That being said, one of the things that don't work so well, one of the things to bear in mind with Onion messages, and it's actually laid out quite clearly in the specification for Onion messages, is that they are not necessarily very reliable. And you can kind of see that because for an Onion message to reach its destination, it would require all the nodes that are picked as a route by the sender of the message to be online and to actually forward the message, just like for a payment. And so sometimes Onion messages can fail, and in that case, it's not the message cannot reach the destination. And the problem is that right now, not many nodes necessarily support the forwarding of Onion messages. And so right now, let's hope temporary solution is that sometimes the sender can reach out directly to the recipient. And for example, it's implemented in LDK that way. If there is no route for forwarding the Onion message from the sender to the recipient, then the sender will establish a direct connection with the recipient. And then in that case, you lose pretty much the privacy advantages. So it should be a temporary solution while Bolt12 is not as widely adopted as basic payment forwarding. But yeah, that's one thing to keep in mind. The fact that it's routed across the network means that it requires some adoption threshold to be able to work somewhat reliably. Yeah, and so I mentioned that the messages are routed, and I said that it's quite similar to payments. And actually, it's quite similar to payments due to the fact that currently in practice, Onion messages reuse the existing network of channels. And so a lot of, it's not necessarily required by the specification, but a lot of the times, a peer will only accept to forward an Onion message if it comes from another node with which they share a channel. And so basically, Onion messages travel through the same links as payments because they travel along channels, and there needs to be a channel in order to forward the Onion message. And so, of course, the core benefit of this approach is that it helps somewhat prevent denial of service because nodes can decide to only accept Onion messages from peers they have a channel with. The issue is that, as I mentioned, it makes it hard to bootstrap the network because, as I mentioned, not all Lightning node today support Onion messages, and so it's hard to find a route inside this channel graph where all the nodes support Onion messages and where you hence can reliably send and receive Onion messages. Hence, now the temporary fix of having the fallback of establishing a direct connection between the sender and the receiver of the message. But as we mentioned, it's not the point of Onion message at all. And then you have the reliability issue, as we mentioned. And even with higher adoption, we would still have some reliability issue. But if we now project ourselves in a world where Onion messages are more widely adopted, then the reliability should be closer and even better, presumably, than that of payments. But it really requires a high adoption for this to work. And then you have latency, of course, because each node in the route adds some latency. And the fact that you require a channel to exist between two peers in order to forward the payment means that you have maybe routes for the Onion message that are longer than what is strictly required. And to that point, that's one of the reasons behind Rosebeef's proposal. And so his proposal is to create an overlay layer for Onion messages. And so basically get rid of this idea of routing along the existing channel topology, and instead creating a separate topology for Onion messages. And so in this proposal, nodes will establish links between each other by exchanging messages on an existing connection. So you already are connected with a node. You do not necessarily have a channel, but you have a peer-to-peer connection with them. And then you establish an onion link on this between these two nodes using this connection to exchange what you need to exchange in order to establish this connection. And then you advertise once an onion link is established. Basically, an onion link means that both nodes agree to forward onion messages on this connection. And once an onion link is established, it can be advertised on the Gossip layer. So just like we advertise channels or node updates. And it's advertised through the node announcement messages, so an extension of these messages. And this way, thanks to the fact that it's broadcast on the Gossip layer, all the nodes can build a graph of onion links. And so they have basically one topology for the channels, one graph for the channels, and another graph for the onion links. But it's completely decoupled, and you don't require a channel in order to route an onion message. And for instance, you can hence have sometimes shorter routes for onion messages than for the payment between the two same nodes, because the topology is not the same. And so, yeah, as maybe I can go back to the post by Roastbeef to highlight this connection establishment I mentioned. So basically, you have an initiator of the onion link and a responder, and basically they will just exchange messages in order to be able to create together a signature, which is the onion link proof. And basically the idea is to be able to prove that both peers agreed to establish this onion link between them. And this way that it isn't possible for one peer to say, yes, there is a link here between me and this other node, whereas the other node didn't agree to that and will hence refuse to forward onion messages. So this idea of an onion link proof is basically that this way when you receive it's basically to achieve the same kind of thing as with Lightning channels and prevent the nodes from adding fake links into their graph. When they see a graph, a link being broadcast on the Gossip layer, they can check the proof and hence be sure that both nodes on both ends of the link agreed to create this link, much like a Lightning channel, for example. And so, yeah, that's what I mentioned. And so this proves advertised on Gossip. So basically, that's what I just said. And now, so I mentioned that they create this this proof using their by combining their keys. So they are using MuSig2 for that. And so currently, so what keys are they using in the first place to derive this aggregate signature, if you want? And so currently, Onion messages reuse the cryptographic keys used for Onion payments. And the idea with this update or this alternative Onion messages scheme would be that we could also decouple Onion messages from Onion payments and basically use a distinct set of keys for that. And we could also implement key rotation for Onion messages since we have decoupled them from payments. And so here, yeah, basically the idea is that we can then rotate key if we want. And this way, so Roastbeef presents this as being useful because, for example, the fact that currently you can't rotate keys means that if a key leaked, then all the onion messages can be deciphered. All the messages that were signed with this key can be deciphered, so there is no forward privacy. On the other hand, so it's true, but on the other hand, traditionally we treat onion messages as something quite ephemeral, so I don't think it would be such a big deal, but maybe I'm missing something here. Yeah, so that's basically it for Rosebeef's proposal. There were some answers to that, so there is Justin's answer. We'll delve into it a little bit more. And then there is also Matt Corallo's answers, who highlight that the reason why the community at large, the consensus was that we should require a channel to exist between two peers in order for a peer to forward an onion message, was that it would provide a good anti-DOS protection, so denial of service, because someone who wants to send an onion message to you needs to have a channel with you, and so it helps a bit in protection against denial of service. And Rosebeef responded to that by highlighting that you could still have this. And so basically when, because in his proposal, basically you have the connection establishment between an initiator and a responder. And basically the responder could have some policies that state that they will only accept to establish a link with someone with who they have a channel. And so you could just fine tune this anti-DOS policies depending on your threat model or depending on maybe the current threat, the current denial of service threat in the network, and you could maybe change this kind of policy over time as the situation evolves. Yeah. Oh, there are new answers that I didn't see yet. Great. So yeah, that's it for this first part. Feel free to ask any questions if you have any, either in the chat or yeah, whatever you like. And now maybe we can go to Clink. So I don't know if you're here, Justin, but once again, if you want to take part, yeah, it would be a pleasure. And so basically the idea of Clink is to use Nostr as a messaging layer between Lightning nodes. And so not messaging as, you know, when nodes exchange peer-to-peer communication between them, because nodes all the time they exchange messages. More to here, the term messaging is more to be understood as interactions between nodes, like what we do with offers, for example, requesting an invoice and sending an invoice and things like that. And so with Bolt 12 offers, really one of the idea was to be able to do this in a Lightning native way. But there are some discussions, let's say, around whether it's an appropriate method or not. And one of the alternatives that I find interesting is Clink, which is using Nostr as this layer to exchange things like invoices between Lightning nodes. And you have offers, so N offers here, and you have also debits, which I'm not sure if the specification for debits is finalized yet or not, but there is this idea that you can also pull payments from nodes. And basically the idea for example, N offers here is that a node will publish a Nostr event with an N offer, so something that resembles a Bolt Wave offer, but it's not Bolt Wave, it's Nostr native. And then by decoding this offer, someone who wants to send money to this service or this other person can publish an invoice request encrypted into a release that was specified in the end offer. So that's what's happening here. So basically, it's a DM, some kind of DM where you request an invoice, and the provider node will okay. So Justin says you are in the bad streaming spot, but can try audio. That's great. Let me try to send you the link. I will need to stop sharing for some time. All right. All right, Justina, I sent you a DM on Telegram. So if you want to try to join with audio, it's great. And we'll see if it works. Yeah. Tell me if once it seems to work for you. I'll share just again. Sorry, not what I wanted to do. And so basically the idea is that, yeah, so basically as with any Nostr interaction, when the person who wants to get paid with the offer is subscribed to the relay, and so they will receive the invoice request, decrypt, check that the invoice request corresponds to a valid end offer, and then respond likewise with a bolted event invoice in a Nostr message, and the wallet of the payer will receive this invoice from the relay, decrypt it, and use the invoice to pay on Lightning as we usually do. Yeah, I see you're here. I'm going to add you to stage. Can you hear me?
I can. Can you hear me?
Yeah, perfect.
Thanks for tagging me.
Yeah, thank you for joining. I hope I didn't say anything too dumb around Clink.
Yeah, what I heard so far, I might be a little delayed on the stream, but yeah, I think you kind of nailed it. My issue with the Onion messages is, of course, the separation of concerns. Lightning is a payments protocol, and we should stick to that. To the extent that Onion messages have worked, have been because it's a payment protocol, and that's kind of a bonding apparatus, to kind of qualify those communications. So it's already pretty unreliable. There's been, not a lot of adoption of it, but those that have used it in hackathons have kind of found out what I predicted to be true, is that with each hop and anything like this, it's going to be unreliable. Latency is going to make real world interactions not pleasant. It's effectively the same architecture as Tor. So anybody that's used Tor, I think, could attest to the fact that it's not a production type architecture that you can use if you're standing in line at the grocery store or something to pay for a coffee. You can't have onionized packets bouncing all over the world and potentially failing and having to retry over and over again. So the more logical solution is Nostr. It's a web server. We know how the web behaves. You have a web server, and it just kind of works. And that's all Nostr is. It's key-based communication. So like Onion messages, you're encrypting. And if you want to Onion, you can bounce off multiple relays, but you can port those relays. We're accustomed to the latency, just, again, because it's a web server. So it just seems like a more straightforward, reliable, production-ready type means of solving these problems, where we need to get invoices from a node to like a web app or somebody else's phone, something like that. And that's really a big piece of it too, is where are we trying to get invoices? We're trying to get them into apps, and that's typically the web. That's something else Bolt 12 can't do. You need to custom compile a WASM thing just to communicate with these Onion messages, as opposed to Nostr. It's all JavaScript and JSON, right? So we can get the stuff where we need it. We can get the there fast. We can get it there reliably, and we can keep those concerns separated. If you don't want to have your identity, your Lightning node's identity. Let's say you have multiple Lightning nodes and you want to use one identity, maybe to load balance them. That's another thing that separating this out with Nostr is capable of. And then there's some of the extensions. I don't know if you had a chance to get to those yet, but we can upgrade Lightning addresses to use these offers. So if you have a Lightning address at, say, a domain, that can now be actually trustless. Because right now with like LNURL, that web server is passing your invoice and it can be intercepted, it can be wrapped. With offers, Nostr-based offers, all the communication is signed and encrypted, so there's no trust involved when you're using an external Lightning address with somebody else's domain. So it just seems to solve a bunch of problems. It's very lightweight. You can see the code on GitHub and implement it, and especially if something like Cursor can implement this in like 30 seconds. So nice and light, and I hope people will start building on it.
Yeah, no, that's great. That's a very interesting point. Indeed, the fact that you can verify that the invoice comes from the node you are actually trying to pay. And so I think you mentioned this. So we'll have some lag with the video, but I'm showing clickme.dev, which is basically the demo you made to demo that. And
that's right. Yep. Yeah. If you click the check address button, it'll actually give you the JSON to see. So this is actually a NIP05 lookup. So for anybody that's familiar with Nostr, you can have like your username add a domain name, and that domain name will respond with some JSON, things like your public key, relays where you can have your notes found. So that's extensible, and what we've done is we've extended that by adding this field clink offer. And that clink offer is, again, encoded. It has its own relay. It has the public key of your Lightning node. So that's something to keep in mind with this, is that your Lightning node has its own Nostr key for communication. So once that's decoded, any app here, you can see what's decoded, the pub key, the relay, the offer identifier. That's what's necessary for this app, this web page, to get an invoice. And there's some other functionality that we spec'd into it, things like price type. I think that'll make this usable in the future for things like subscriptions, where maybe you have a monthly payment, but that price changes because it's maybe tied to a fiat exchange rate. And you just clicked it there. You can see how quickly you click that button. It went over Nostr and received an invoice from my node. So just as you would expect from any centralized web-based platform, it works flawlessly, because that's really all we're doing, is we're just using web technology.
Yeah, and so you just need to run. How does it work on the Lightning node end? In order to, do you just run something on top of it that handles the Nostr part with the Nostr identity, quote unquote identity, and signing the messages?
Yeah, so we have our own Lightning node that's it runs off of LND. It's a Node.js service that runs on top of LND, and that handles. We do a bunch of things with that. We do metrics and management and various enterprise oriented things, but that also is the Nostr layer for us, and that's lightning.pub. That's a full featured wrapper for LND. It includes Nostr-based accounts, and that's really meant for, if you have a Lightning node, you want to share it with friends, family, customers, apps, you can do that completely over Nostr. So you can be like your own wallet of Satoshi, and you just invite people to your node with an npub. You give them your node's npub, and they can connect Shock Wallet to your node. But you don't need to do that. Like, again, the protocol is very light. You can implement your own, just lightweight, responding service to any Lightning implementation. And that's kind of another nice thing about it, is not part of the Lightning spec. So it's easier for people to opt into it, and we can be more flexible with it. We're not getting into the inner workings of everybody's, Lightning protocol that they're running. This is a very simple kind of quote unquote soft fork into the Lightning ecosystem.
Yeah, basically it's really an alternative to to what we do with LN URL, with the added benefit of having this verifiability of what you receive, checking that what you receive actually comes from the node that you're trying to pay. And
that's right. Yeah, and that's kind of been a big, drawback with LNURL is that if you're running a node now, if you want to use LNURL, you also have to set up a web server.
Yeah.
And that web server, you also have to have a domain, and then that domain has to also have an SSL certificate. And if that node of yours is behind, like your residential internet connection, you need to reverse proxy that public-facing web server back to your node. And then anything that uses it can't verify that an invoice was actually paid because you can't get, there's LNURL verify, but that doesn't allow a service really to reach into your node to verify the status of an invoice. So by making the transport Nostr-based, the key-based, signed, encrypted nature of it, we can traverse all those networking issues and get around the web server side of it and add bi-directional communication that's otherwise not possible with regular LNURL.
Right. Okay. Interesting. And I'm trying to see if it can be somewhat abused. And for example, you mentioned using the so having the Clink offer field as an extension to what you get with the NIP5 verification, what you currently get. And if you're not using your own domain, and so could, for example, the web server that responds to this NIP5 verification request just put their own offer in there, and then senders would not be paying you, but actually the entities that runs the web server.
Yeah, ultimately the web server could serve any JSON that they want from their web server. But when you make these events, when you're attesting to your NIPO file address or alternatively an offer, you're creating a signed event. So it would be possible for an application to verify that you signed an event stating what your offer is. So if those don't match, a client could see that it was counterfeited. So that's kind of not baked in by default with NIPO 5 because NIPO 5 doesn't do that. But it would be trivial for a client that is, let's say, doing high value payments or something like that, something where you need it to be secure, to add that extra step to make sure that the recipient has signed for or attested to their NOFR string.
Yeah. Okay. Great. Yeah. So that's cool. And yeah, to go back to Bolt 12, do you see maybe any merit to having Bolt 12 as maybe a fallback mechanism if we have, I don't know, some issues with DNS or the traditional web at large? Because some people may see Tor, for example, likewise as also some fallback mechanisms that doesn't work really well, isn't necessarily very quick for day-to-day browsing, for example. But then when you're trying to reach some resource that are, for example, blocked in your area, then Tor is very useful. Do you see maybe Bolt 12 as being some kind of fallback when other things don't work because they are censored or things like that?
Actually, quite the opposite. So Bolt 12 is a big liability because these onion messages, they're very distinct traffic. So if you're in a situation like you're in a hostile network, let's say, even if you're at like an airport or something that doesn't allow kind of non-standard traffic, that's easily censored, or packets are lower prioritized, things like that. Whereas a Nostr relay, you don't need DNS. Like, it's common that you have SSL, you have DNS, but a Nostr relay can just be an IP address with HTTP because your encryption is already done at the Nostr level. So you don't need SSL to use NOFRs. So it's good from that standpoint. You don't actually need the SSL if you have if DNS is under attack, let's say, or you don't want to rely on it. You're not reliant on it. But you are reliant on the network with Bolt 12 because it's not hiding in HTTP traffic. So with an offer, you can be at the airport and it looks like regular web traffic, regular HTTP or regular HTTPS traffic. It's not kind of sticking out there like a sore thumb, like Tor or onion messages are. And as far as the Lightning addresses, if you're adding a offer-based Lightning address to say something like a contact in a social app, that's bypassing DNS completely because you're just caching an offer, which is similar to what Bolt 12 would do, but Bolt 12's Lightning addresses, Matt Corallo has made a BIP for using, I think, TXT records, some kind of DNS records, as an alternative to LN URL for Lightning address. That is it's literally based on DNS. It's literally a DNS record. So, the Nostr-based offers, that solves the DNS problem. It helps the privacy issue because it's hiding in plain sight with regular HTTP traffic. It'd be much more resilient in my opinion.
Yeah, but then if onion messages are censored because they are more easy to distinguish, then I presume that Lightning payments themselves would be censored because they kind of look the same.
Well, so that's kind of and that's a knock against mobile node. So if we go back to the airport use case, I've been long of the opinion that most of the things that have been done wrong in Lightning have been because people are trying to use nodes on their phones. Like, you don't run an email server on your phone. You don't run an IRC server on your phone. Like, servers are servers. So if you're at that airport and you're trying to use Bolt 12 with a mobile node, you might have a hard time getting out on that constrained network. We saw this at some Bitcoin conferences recently where the Wi-Fi was just really bad. Nobody could make Lightning payments. My wallet, on the other hand, worked fine. Shock Wallet, because I was using Nostr to connect to a Lightning node that was not at the conference. So I was just getting my Nostr events out from my phone, which is a thin client, to my Lightning node, remotely hosted on a VPS, and it was working flawlessly because all that heavy traffic was happening at the data center, where the only thing happening between my phone and the node was these Nostr events, which are just a couple hundred, K bytes of JSON, really. So I have not found a scenario yet where this is less resilient than native Lightning or Bolt 12.
Yeah. No, maybe the only scenario I can come up with is if you're trying to transact locally, and then you can use some basically not the internet, but it's arguably a very niche scenario, and okay, no, very interesting. And privacy wise, you mentioned the fact that you can have maybe the basically rebuild some kind of onion routing, but at the relay level. Is that what you referred to?
Yeah. Like, if that's a major, it's not personally a concern for me, but I know some people do share that. There is a Nostr-based protocol for onion messages where you basically, I think it's called gift wrapping, like NIP17 gift wraps. Okay. So there's no reason you couldn't implement that on top of this to have that, use multiple relays. Another thing that you could do short of that is your Lightning node could have as many Nostr keys as it wants, so that the identity is completely decoupled. So you could have, your public Clink offer that's attached to your social identity, but then your Lightning node could also be listening to a completely different key, or could have ephemeral keys for different applications. So unlike, the current state of Bolt 12, where the communication layer is tied to the monetary layer, since this is an overlay network, you have complete flexibility to, use ephemeral keys or disparate keys, things of that nature. So,
right. Do you need to change the offer when you change the key of the?
Yeah. So each key would be a different offer. Yeah. So those would be unique strings. So like you have your public one that just kind of resides in your NIP05 profile, but then you'd feed a different offer string to different apps. And in the spec, we also have the rollover, so you can roll over the offer. Let's say you have one Lightning node and you have a second one for HA backup, and you deprecate the first one. You can send a response. It's almost like an HTTP 302 where it's forwarding. That old offer can reply with the new offer. So you have the ability to kind of roll those things.
Yeah, great. And this way, it's still publicly visible that the new offer is a child from the previous one, kind of, and
Right. Yeah.
yeah,
That kind of rolling technique is doable. We're really copying tried and true web practices to the extent possible with this, with the benefit that we can get around those like DNS issues.
yeah, awesome, great, okay. Is there anything more that you want to highlight around Clink or?
I think that pretty much covers it from the offer side. Obviously, the offers are the first thing that we tackled because there's LNURL has been subpar. That kind of led to Bolt 12, which is just bad. So offers are obviously the most important thing. But I think you mentioned the debit spec. That's basically the inverse of this, where instead of a Clink offer, you can publish a Clink debit.
Right.
And that allows a remote service, let's say like a video site or a Nostr app, to request that you make a payment. And the way we have that implemented in Shock Wallet is it just pops up. Do you want to accept this? Do you want to create a rule? Do you want to ban this key? And that'll allows a much easier way for services to bind to your wallet. You don't have to like generate a key and hand it to that service and then remotely control your wallet. This would allow like someone that like an actual service that has just one Nostr key that has a reputation that you want to define rules around, a much easier onboarding experience to that. And that also helps with subscriptions as well, because you set a rule that says, all right, I'll allow this thing to deduct $5 a month or something like that.
Yeah.
And then lastly, it's not published yet. It's in another branch, is an API basically for offers that allows a remote app to create its own offers and update them. So let's say it's a marketplace of some sort and you're selling a bunch of different products. You should be able to upload your products into that, that marketplace's interface, and it can reach into your Lightning node and create different offers for the different SKUs that you might have, like a t-shirt, a hat. They might all be distinct offers with distinct prices, distinct callbacks to your fulfillment center, something like that. So that's the third spec that should be coming soon, and then we'll be able to demo a bunch of this and get some apps out there for more people to play with beyond just the demo site.
Awesome. And going back to debits, how does it compare to Nostr Wallet Connect? Because it's when you think about pool payments on Lightning today, I think it's the most broadly adopted protocol right now.
Mm-hmm. Yeah, there's definitely more overlap on the debit side than there is with offers. NWC does not have an offers equivalent. The debits, it's a little bit more similar. This is an improvement in my opinion because it's more secure from the standpoint that you're not generating a pre-shared key and then having to fumble that over. It's more scalable for services because now they're not managing secrets for every one of their users.
Right.
It leverages the reputation of Nostr, unlike NWC. Everything's ephemeral with NWC, but now we can build automation around reputation using this by basically whitelisting pub keys instead of creating the shared keys. Kind of flips it on its head, and I think it's just better UX too. It's much easier for a normie, let's say, to get a pop-up. They're very used to getting like a 2FA notification on their app where they accept something. That's the UX that we have here. Is you enter a Lightning address into a service. Let's say that's like a Stacker News or something. And then you get a pop-up in your wallet that says Stacker News wants to spend from your wallet. And then you can just click OK. That's a much more familiar UX. That's a much more secure UX. It's more scalable from the Stacker News side in that example. I think that's the biggest thing about the handshaking is a big upgrade there. Otherwise, remote spending, it's a Nostr API for remote spending, but it's how you bootstrap that, I think, is the big difference.
Yeah, because in Nostr Wallet Connect, you just have to basically you have the secret straight in the URL or in the QR code that you're sharing with the service, and each connection is their own secret. Whereas here, it's quite different actually, and yeah, okay, no, that's interesting, and the fact that you can uh, because you can also imagine having uh, uh, you know, a bit like what we have with follow lists or mute lists right now on Nostr, but you could add this with reputation, as you mentioned. And
Mhm.
this way, you could be sure that you're actually talking to the real Stacker.news, for example. And
Yeah, and even let's say that breaks down. Let's say Stacker News got hacked and their private keys were leaked. Your web of trust in Nostr could inform you of that in something like this and automatically revoke Stacker News's permissions to your wallet.
yeah,
Whereas with NWC, it's a one-to-one relationship. There's no way about doing that, right? It's you wait until your wallet's been drained before you remove it. So this kind of gives us a whole bunch of new primitives like around what Nostr does. Nostr is identity and reputation. NWC isn't taking advantage of that. This kind of gives us the ability to take advantage of that.
no, that's great. No, that's really a very interesting perspective. Yeah. Awesome. And is there anything else you wanted to share on?
Yeah, that's pretty much all I got from the protocol side. Of course, it's still pretty early stuff. I'm still working on materials for this. You caught it early. I appreciate you tagging me. Let me know you're going to be talking about it today. Anybody that would like to play with it, shockwallet.app is our reference wallet. And that, again, connects to lightning.pub, which is the Nostr-based Lightning node. We have an SDK for this. So if you're building an app and you want to make it easy for people to get invoices or make payments from their wallet, we have an SDK very early. So any and all feedback is appreciated. Feel free to reach out to us. We'll help with implementation if need be. All the feedback in the world helps move all this stuff forward. So I invite anybody to have a play with it and reach out to us.
Awesome, great. And yeah, where can people reach you? It's on Twitter, on Nostr. What's the go-to?
You'll see our socials on shockwallet.app, but shockbtc on Twitter, shockbtc Telegram. All the links there, and yeah, I'm on Nostr, and of course our github.com/shocknet.
Perfect. Awesome. Great.
All right. Pleasure being with you, man.
Yeah, thank you so much for joining. Yeah, great. Awesome. Thanks again, Justin. Yeah, that was really interesting. It was really great. I don't think I fully grasped the scale of what you're trying to build just yet. So it's really interesting. I'll definitely keep an eye wide open around this. And so, as Justin mentioned, if you want to play around with Clink with Shock Wallet, so it's shockwallet.app. Yeah, feel absolutely free to do so, and every feedback is valuable, as Justin said. Great. Let's move to the last part of today's session. Basically, it's a few smaller things that I still wanted to mention. We've got some news from some wallets. One of the big news from last week was this beta preview from Wallet of Satoshi new self-custodial version. So I'm putting quote around self-custody because we obviously don't know yet how this will work. If I had to guess, based on the previous communication from Wallet of Satoshi, the timing of communications, So I think it's pretty sure that it's either using Spark or using Liquid and swapping between Liquid and Lightning, like Aqua does, for example, or Misty Blitz, or maybe it's even using the Nodeless SDK from Breeze. I would tend to think that it's more probable that it's using Lightning to Liquid swaps and vice versa. So basically, a Misty Breeze or Aqua model. Just because, if I remember correctly from the timeline of when they first announced going self-custodial, I think Spark wasn't mainnet yet, or was had just gone mainnet, and so it would make more sense for me if it's using Liquid swaps. And so hence the quotes around self-custodial, and you could put some quotes as well if it's using Spark, because there is some trust involved in Spark as well, but it's definitely not the same trust model. On Spark, you are required to trust during transactions, whereas when you're using Liquid, it's actually quite the opposite, and you're trusting the Liquid Federation to not rug pull as long as you're holding some liquid balance. So hence the quotes around self-custodial, and there will be a space tomorrow. Let me try to see if no, I didn't, but I think it was announced by John Carvalho. Let me try to quickly find this. Trying to find the exact time. Just went up too far. Yeah, here it is. So there will be, I think it will be interesting. There will be a space. So it's tomorrow at 5 p.m. So my 5 p.m. is CET time. So yeah, depending on where you live, adjust accordingly. So it's tomorrow 5 p.m. CET around Lightning, Liquid, and wallet custody. So whether I think one of the topics will probably be around whether we should call Liquid wallets with Lightning capabilities self-custodial wallets or not. And so yeah, it will be an interesting debate. I hope so, at least. So that's for Wallet of Satoshi. Then there is some Spark-related news with two wallet integrations. So we quickly mentioned Spark, not so quickly actually, a few weeks ago. And so a refresher, Spark is basically a new state chain protocol. So there was Mercury back in, so I think Mercury is still around, but I don't know the exact status of the project. But so basically, Spark is a state chain protocol. So you have a centralized server in the middle of all transactions, but the server doesn't have access to the funds. And it requires for the server to steal funds, it would require the server to collude with another party in order to be able to steal funds from someone. And on Spark, actually, you can have multiple operator in a single entity. So this dilutes the risk and the trust assumptions that the trust required towards the server, because the server is actually not one single entity, but multiple entities. And you have, of course, unilateral exit, which is one of, to me at least, it's the base requirement in order to call something a layer 2. It's that you can have unilateral exit. And one of the big innovations with Spark is that you can have arbitrary amounts. That was one of the big downsides with Mercury. Mercury was much more like a virtual open dime, and you would have to transact always the same amount. You couldn't split a coin on the state chain into smaller denominations, whereas you can with Spark. And on the other hand, one of the downside of Spark is regarding privacy, because with Mercury you had blind signing, So basically, a bit like in eCash, the Mercury server doesn't know the details of the transactions occurring, whereas with Spark, they have more data available. And so basically, when you are on when you're using Spark, what you hold is these state coins, so these off-chain representations of Bitcoin, which you can get back unilaterally. Of course, it always requires publishing some precise transactions with or without time logs and things like that. And the Spark entity also runs a Lightning service, a Lightning gateway, which you or someone else runs a Lightning gateway, which you can use to do Lightning transactions from your Spark balance. And so that's for the refresher around Spark. And so we had some Spark integration. We had a web version of Blitz, which I tested and it works. And so you can just go to wallet.com and try it out. Of course, it's still very beta, so don't put too much money, but you can just receive funds via Lightning and it will go to your Spark wallet. And you have also some Spark address that you can use to receive directly on Spark. So you need to be on the same Spark server, of course, to be able to send money directly on Spark. And you have so it's an announcement of an announcement as well, but you have some some early footage of Spark being available in Blue Wallet as well. And so Spark, I think, can qualify as self-custodial, at least more than Liquid, I would tend to say. And so it's great to see this option being pursued as well on parallel with Liquid swaps. And another one last thing which is also great is so it depends on your stance on Boltwave's offers, of course, but LND has been a bit lagging around Boltwave's offers, so they have different priorities, and so a team, independent team, is working on something called LNDK, which is basically bringing some features from LDK to LND. And so Maurice here just announced last week that they did presumably the first LND receiving payments through a Boltwave offer on mainnet. And so basically you'll have, it's not shipped yet, but you'll have offers in LNDK. So this basically LNDK is, I think, if I recall correctly, it's basically a small daemon that you can run on top of an LND node, and that brings you Boltwave capabilities, for instance. So I just wanted to mention that as well. Great. So that's it for today. As I mentioned in the beginning, we are going to take a summer break. And so we'll come back around September. And we will also take advantage of this summer break to refine the format of this kind of sessions. As you probably know, the goal of the lab is also to have some practical projects and things like that. Something a bit more community based. In this first iteration, it was maybe a bit not exactly what we intended at first, and so we're going to try to refine the format a bit in order to see to find something that we're really happy with. So that's it for today. Thanks a lot for joining us. Thanks again, Justin, for joining me on the live. It was really interesting discussion. I really appreciate you joining, especially since it was quite short notice. Thanks again, everybody. Have a great summer, and see you in September for the season 2 of the Plumbee Labs Lightning. Bye bye.